This is chapter 4-2, Congruence in Triangles. Please copy your codes. Let's start with some definitions. In 4-2, when two figures are congruent, such as the triangles we see here, you have two triangles or two hexagons or three triangles and three pentagons or four heptagons. If they're all congruent to one another, if the two triangles are congruent, we use the congruent symbol here. Then that means that if two triangles are congruent, then they will have corresponding angles and corresponding sides. If I have three hexagons and all three of them are congruent, that means that all of their angles will be congruent and all of their sides will be congruent to one another. If I have 10 pentagons, then that means the 10 pentagons, all of their sides will be congruent and all of their angles will also be congruent. Well, let's look at these two triangles here. Triangle ABC, and I also have triangle TNH. These two triangles are congruent by angles and sides. Let's look at AC corresponds to TH. Same length, we know that by the marker. Also, BC is congruent to NH. Same length with the same marker. And BA is congruent to NT. And then the angles are congruent. A corresponds to angle T. Angle B corresponds to N. And because these two are congruent, automatically the third angles are congruent. How is that possible? Let's say this angle here, angle A is 90 degrees. That automatically means that angle T is 90 degrees because they're congruent. And if this angle here is 50 degrees angle B, that means that angle N is also 50 degrees. Well, just go by triangle sum theorem. You know the interior angles of a triangle must equal 180 degrees. Well, this is 140 degrees, so that means that we can find the missing value H, and 90 plus 50 is 140. 140 away from 180 leaves us with 40 degrees. And even if you did the same thing to find angle C, still using the triangle sum theorem, the interior angles have to equal 180 degrees. And 90 and 50 make 140, and 140 away from 180 leaves this at 40 degrees for angle C. So automatically the third angle, the first two angles are congruent on one triangle, and they're congruent to the two angles on the second triangle. That automatically means that the third angle will be the congruent. Anyway, going back to corresponding angles and sides. Looking at these two triangles, right? When I want to say that two shapes, whether they're two triangles, two pentagons, two hexagons, when I want to say that two shapes are congruent to one another, you have to write each of the vertices in the exact order in which they are congruent to the size and shape of the other shape or object. So what does that mean? If angle A corresponds to angle T, when I say triangle ABC, I have to write what corresponds to A. Well, triangle ABC, what corresponds to angle A? Well, when I look on the other triangle, it's angle T. So I have to write them in the exact position. Which angle corresponds to B? Well, on the other triangle, TB and H, angle N corresponds to angle B. So I put it in the second position because I said that B corresponds to N. And finally, angle C corresponds to what on triangle TNH? Angle H. So they have to be in the same position. That tells me even if this picture was not drawn, if this was missing and I was only given this statement, triangle ABC is congruent to triangle TNH, I know what angle corresponds to what. Angle A corresponds to angle T, angle B corresponds to N, and angle C corresponds to H. They must be written in the exact order in which they correspond and are congruent to the same size and shape of that particular object. So here it is. Corresponding angles. That means that, as we've already stated, angle A corresponds to angle T. A corresponds to angle T, so I write it like this. Corresponding angles, angle T is congruent to angle T. Angle A, excuse me, is congruent to angle T. Okay? And then that also means that angle B corresponds to N. If I go back here, angle B corresponds to angle N. That means that they are congruent, and I can say angle B is congruent to angle N. And then finally, angle C is congruent to angle H. Angle C is congruent to angle H. And I wrote that in the same position, the third position for each. So this is to tell me that corresponding angles are congruent here. A corresponds to T, angle B corresponds to angle N, angle C corresponds to angle H. Now I do it by sides. If I do it by sides, what am I saying? Side AB is congruent to what? Side AB. Side AB corresponds to what? TN. If I'm looking here on the diagram, you should be able to look at it. AB goes to TN. Well, let's look. AB to TN. Okay? AB is congruent to TN. Now listen, this is important. We can no longer say NT when we're trying to say congruent. If I say angle N, put this vertex N and then T, I'm saying that A corresponds to N, and that's a false statement. N does not correspond to A. I must write it in the exact position as it corresponds, because A corresponds to T. When I say segment AB, I have to write T first and then N. This time it matters. I can't, even though TN is the same as NT, when I'm trying to say it's congruent to another segment, I must put it in the same exact position as the angle or vertex it corresponds to. So AB corresponds or is congruent to TN, and then AC is congruent to TH. Let's look at here. AC corresponds to TH. And again, I do not want to say HT. A corresponds to T, so that means I have to write T first and then H. And I can get that right off of the statement here. Okay, AC corresponds to TH. I can get that without even a drawing, just by looking at the statement, the corresponding statement. And finally, BC is congruent to NH. So we have here BC corresponds to NH. And again, B corresponds to N, so I write N first and then H. All right. Here's Theorem 4.3, which I've already briefly talked about, which is the third angle theorem. If two angles of one triangle are congruent to two angles on another triangle, the third angle has to be congruent. I've already done that up here when I talked about A is 90 and T was 90 and then B was 50 and N was 50. That automatically meant that the third angle had to be congruent. That's called the third angle congruence. Third angle theorem, which says that if two angles are exactly the same measure as 2 on the other, that automatically means that the third is going to be corresponding or congruent to the third angle. Okay? So here if I have a triangle, ABC, and I'm looking at it, A corresponds to E, so I have to go E, F, G. Okay? That means that C is congruent to angle G. And think about the interior angles. They have to equal 180 degrees. So I can find out that missing angle there if I wanted to find it. And here we have. Okay, so we know that the interior angle must equal angle AB, triangle ABC, 180 degrees. So if the first two angles have the same value, the third can be subtracted from 180 degrees to all equal 180 degrees. We've done this already. It's just a bunch of words to say, I add these two together and subtract it from 180 degrees and I can find that one. Or if they don't give me G, but I know that these two are congruent, A and B, angle A is congruent to angle A is congruent to angle B, and angle E is congruent to angle, let me back up. If angle A is congruent to E and B is congruent to F, I can find angle G if they tell me that angle A is 110 degrees and this is 30 degrees. I can find out the measure of angle G. How do I find the measure of angle G? Well, because these two are corresponding angles A and E, and B and F are corresponding, I can add this 110, plus 30 equals 140, and then I subtract the 140 away from the 180 degrees, and that tells me that this angle G is the same measure of angle C, and that this will be 40 degrees. Okay, that's just an example. But here's us going further. Here's the third angle theorem. Here's another example. Find the missing value of x. Okay? And x is over here. I know that angle S is congruent to L. I know that angle N is congruent to R. And I know that M is congruent to angle T. So that means what? I can come in here and fill it in. I know that angle S is going to be 65 degrees because it corresponds to angle L, and it's the same measure. And angle R is also going to be 55 degrees because it corresponds to angle N here. Okay? That also means that M is 2x plus 30 degrees. That's just us starting it and setting this up. Okay? And we know, again, as I've already verbally stated, that the measure of angle N is equal to the measure of angle R. These two are congruent. And the measure of angle L is equal to the measure of angle S. And notice I put the equal sign in here and not congruent. And I also have the measure of in here now. Remember, when I say the measure of, I actually want the number. And I did write the numerical values. Equal and congruent, same but different. Remember, we talked about it. Okay? Knowing that the measure of angle N is congruent, is equal to, the measure of angle R, and the measure of angle L is equal to the measure of angle S. Therefore, that means that the measure of angle M is equal to the measure of angle T over there in the corner. We can use the triangle angle theorem to solve for X. And to do that, I can say simply, by substitution, the measure of angle L, the measure of angle L plus the measure of angle M plus the measure of angle N, the measure of angle L plus the measure of angle M plus the measure of angle N is equal, interior angle has to equal 180 degrees. I can substitute. The measure of angle L is 65 plus, I just put M as U, okay, plus 55 degrees for N equals 180 degrees. I find that that's 120 degrees plus U equals 180 degrees. How do I find out what the measure of U is? Okay, U is 60 degrees because I subtracted these two. And that means that the whole measure of this angle is going to be 60 degrees. That's the measure of this angle. But that doesn't tell me what X is equal to. How do I solve for X? The measure of angle M is 60, but what is X? Well, the measure of angle M, they said that the measure of angle M is 2x plus 30, and they also tell me that that's equal to 60 degrees. I set them equal to one another because I know that M is also, I can write it as 2x plus 30, or I can write it as 60 degrees. Subtract 30 on both sides. 2x is equal to 30. Divide both sides by 2. X equals 15. So x is equal to 15. And we'll pause here for part 1 of 4-2.